friends, Dr. Lewis here again. We are going to continue with our work on geometry. We're working on this standard 4G.A.1. Remember, it's 4th grade geometry. A because it's the first one in the geometry section, and 1 because it's the first of those standards. So standard 4G.A.1, and today we're going to be talking about angles. So we've got these two learning targets. The first one says, I can use right angles to determine whether angles are equal to, greater than, or less than right angles. So we're going to need to be working on some right angles today. And then the second target is I can draw right, obtuse, and acute angles. And of course, you'll probably recognize those words from our work in Number Corner from our calendar work. So let's go ahead and get started. Let's go back to our work from yesterday and just talk about what an angle is. These are all different examples of angles. Remember, an angle is the figure formed by two rays or line segments that share an endpoint. So from our notes yesterday, you can remember that an angle is formed by two rays or two line segments that share an endpoint. So in these images, wherever the two line segments or rays come together, that's their shared endpoint. Okay? All right, so we are going to work on using right angles to determine whether angles are equal to, greater than, or less than right angles. So let's start with our definition. What is a right angle? And here's some images of right angles, and you can see they all look really similar depending on how they've been turned, which direction they're facing. They all still have something really similar in common. And a right angle is an angle with a measure of exactly 90 degrees. So I'm going to write that in my notes, and you can too. It's an angle with a measure of exactly, that's really important, 90 degrees. So what that means is if I were to take out my handy dandy protractor, I would be able to line it up, and wherever I lined it up, this measure right here of this particular angle would be exactly 90 degrees. That's why they have a square right here. That square represents that this is a right angle, that it measures exactly 90 degrees. So lucky for me, I have graph paper to help me out. If you don't have graph paper, you can use the edge of another sheet of paper. You can use a ruler if you printed one of the ones that I provided for you, or just try to be really careful because I'm going to draw a really straight line segment here and another separate straight line segment to form my right angle. So here's my first line segment. You can see it straight up and down. And here's my second line segment starting at this endpoint right here. So looks a lot like the letter L. Remember, this could be turned or moved any direction as long as it has exactly 90 degrees right here, and that means I can form a perfect square. So this is a right angle. So what we're going to do is we're going to use these right angles to determine whether angles are equal to, greater than, or less than right angles. So that's what you're going to be working on today in your Zearn lesson. So let's use these angles from our example. This angle looks pretty much exactly like mine, so I'm just going to cover mine up a little bit. So this is exactly 90 degrees. So we're trying to figure out if these angles are greater than, less than, or equal to 90 degrees. So let's take a look at this angle right here. Is this angle greater than, less than, or equal to 90 degrees based on this example? Nice job. It is less than 90 degrees. It has a much smaller arc right here, which means it's less than 90 degrees. And we're going to talk about what that means. What about this angle right here? Does this measure greater than, less than, or equal to 90 degrees? Nice job. It's greater than. You can see the arc is actually longer from here to here than it would be here or even here. So that angle is greater than 90 degrees. All right, let's look at them in some figures, some two-dimensional figures. Like, for example, this triangle. This triangle has three angles, one here, and one here. Let's look at this angle. Is this one greater than, less than, or equal to 90 degrees? Yep, it is less than. What about this one? Nice, it's greater than. And this one. Another one that's less than. So it has two angles that are less than 90 degrees and one angle that is greater. Now what about this rectangle? What do you notice about this rectangle? It has four angles and they're all exactly 90 degrees. So this one actually has four right angles. So again, remember, a right angle is an angle with exactly 90 degrees. So you are going to be using right angles to determine if an angle is greater than, less than, or equal to that right angle. That's what you're going to be working on in Zearn today. All right, so now let's go into our next target. We are going to draw right, obtuse, and acute angles. So let's talk a little bit about what those are. Obviously right here we've got our right angle down. So we're going to go ahead and draw an obtuse angle. Again, you probably remember this from our work in Number Corner, but here are some images of obtuse angles. And what do you notice about them? They're greater than our right angles. So the definition of an obtuse angle is an angle with a measure greater than 90 degrees and less than 180 degrees. Awesome. So let's pick one of these obtuse angles to draw. Remember, it's got to be greater than this right angle. So what I'm going to do is I'm going to use this right angle as a model. I'm going to make this line each one of these line segments greater than this one and this one in how they form the arc in the middle. So instead of going straight up and down, I'm actually going to take it a couple of places over here, and then I'm going to use the diagonals. And I can go straight across here, or I can go up here. I'm going to go straight across. So it's like I took my right angle and I just went and brought it down a little ways. So this arc right here is actually greater than 90 degrees. So there's my obtuse angle. Again, this is probably a review for you because you remember doing this in Number Corner. All right, so let's talk about acute angles. Here are some images of some acute angles. I bet you can start to see, based on what we've just talked about, how we could define an acute angle because we're basing it on our right angle as our benchmark. What do you notice about all these angles? That's right. An acute angle is an angle with a measure greater than 0 but less than 90 degrees. That's really important. Yes, it's more than 0 degrees. It's not just one ray or one line segment, but it's still less than 90 degrees, so it's going to be more together. The line segments are going to be closer together than our right angle and definitely more than our obtuse angle. So let's go ahead and write down that definition. So again, an acute angle is an angle with a measure greater than 0 degrees and less than 90 degrees. That is the key right there. Less than 90 degrees. So let's use our pictures of right angles and obtuse angles to help us draw an acute angle. We want these two line segments to be closer together so that that arc is actually smaller than our square right here or our large arc in our obtuse angle. So what I'm going to do, kind of like with my obtuse angle when I went that way to make it wider, I'm actually going to go this way to make it shorter. So I'm using this as my baseline. So I'm going to bring it in a little bit. And then same thing, I'm just going to keep my line straight at the bottom. And you can see it's not perfectly up and down, so it's not a right angle, and it's not greater than a right angle. It's actually less than 90 degrees, so it's an acute angle. Nice job. So today in your work with Zearn, you're going to use these right angles to determine whether the angles are greater than a right angle or less than a right angle. And you're actually going to have a chance to practice drawing right angles, obtuse angles, and acute angles. So that is exactly what you are going to be doing in Zearn today. So remember, do your best, and I can't wait to see what you do. Good luck. Bye.